Good morning, everyone. In the last session, we discussed about the important concept called the legacy classes we discussed it. So those are available as a part of collection framework. Okay. So today we'll try to discuss another important section called stream API. So if you remember in the earlier, whenever we are trying to discuss with the collection framework, so we discussed some of the lambda related information. So along with that, so today another important concept we need to discuss it. So that is called stream API. So stream API is also it is newly feature added from the 1.8 onwards. Okay. So basically, so what exactly it will give you the stream API. The stream API basically it will provide some of the most significant so domination of the power of the lambda. So basically it will give you the power of this particular lambda. Okay. And another important section basically what we can understand is here we can understand the stream it is going to operate the data. So whatever the collection of data we use here, so based on the collection of data, it is going to be processed the data. Okay. So not only the collection of data, or it can process with the array of objects. So if you remember, we'll try to create multiple records using the array. So using the array also, we can process the stream API. Okay. And another important concept basically, the stream itself, it is not going to provide the storage capacity. So this is very important we need to understand here. The stream API, it is not going to provide the storage capacity. So only it will provide the operation on the whatever the collection of data we are going to have. So which collection it is going to provide the storage capacity? So that is we discussed like array list, linked list, so hash set, linked hash. So these are the classes it will provide the storage capacity. Getting the point. But here the stream, so just it is going to operate the collection of data. So this is what we need to understand here. Okay. So basically, so this is the main purpose of this particular stream here. So just it will try to perform the operation based on the collection of data, array of data, and internally it is not going to provide any storage capacity. So along with that, so if you are trying to work with this particular stream API, what exactly we are going to get here? Here we are going to get the power of lambda, how we can use with the help of this particular stream API. So just we discuss about the lambda related discussion. So with a simple example, if you remember, so this is the package we are having lambda. Now what we are doing is, so this is calendar demo we are trying to create. So now you can see, so this is one of the functional interface, my class function, and where we are implementing, here we can see, so this is a constructor reference. Okay, so this is the constructor reference. So what exactly the constructor reference will do? While creating this particular object, here you can see my class.new with and it is the function we are getting. And after that, what we are calling the apply method, and we are getting the particular information here. So now if you see the basic lambda demo, here what we are doing is, here my number is equals to, so here we open the lambda parameter and arrow, it is going to differentiate the lambda parameters and lambda body. So this is a lambda body. Okay, so this is the basic example we discussed in the earlier example. So just go through the lambda related example so that we'll understand what exactly the lambda will do now. And this particular lambda, if you want to get more familiar, you can work with the stream API. Okay, so now we'll see what are the basic stream example we are having. So before discussing this particular lambda, now what we can do, so we can create the package. Okay, so this is the stream API I'm trying to create it, and here I'm going to work with a stream demo. Okay, so stream demo. Now here, what I'm doing is, so I'm going to provide the basic stream API. So which package basically it is available, the stream API here. Now if you understand here, so base stream. Okay, so this is a base stream. Now if you see here, java.util.stream. Getting it? Now whatever the collection related we discussed is java.util only. So under the util, now what we are doing now, so we are trying to discuss one more important package called stream. So under the stream package, now we are going to have the basic interfaces classes, whatever we are going to discuss here. Now this is the base thing we are having. Now what exactly the base thing will do now? What exactly the base thing is doing? So if you remember here, so this is the package we are having, and here you can see base interface for the C. Okay, so normally when we are trying to work with the collection part 1, part 2, part 1 the collection interface is the base interface, for the part 2 map is the base interface. So same way when we are trying to work with this particular scene, so this is the base interface. So what exactly it is providing it? So which are the sequence of elements supporting the sequential and parallel. Okay, so if you want to execute the particular data with one by one or at a time. Okay, so this is going to be supported here. Now how we are creating, here you can see. So this is the collection object here. Based on the collection object, we are calling the string and we are doing the filters, we are doing the map, and we are doing the sum here. So we'll see what exactly the filter, map, and all the operations will do. But what we are doing is so simple. The same basically it will try to operate the on top of the collection data or on top of the array of objects. Okay, so this is we need to understand. When you show the collection classes, then you show all the existing methods of the closed loop. But how and also all of these classes and understand. So if you remember, so we created the so if you remember basically what we did here, so we provided the basic class, abstract classes and interface, and along with that we provided the hierarchy, how exactly the each and every interface class is used. So let's say, so if you have the simple example called array list. If you go to the array list here, this is one of the implementation class. Now this is the one abstract class, and it is implementing from this particular list. Okay, so if you know the inheritance concept, you can easily understand this collection framework easily. Okay, this is the relation we are having. So if you know the relation, first the collection is the top interface, and one part basically it is extended the list here. So whenever it is extended, the inheritance basically what it will do, the super interface functionality directly we can access into this particular list here. So when we are going to access it, whenever we are using the keyword called extension. So here only the implementation class you can see here. So what is the implementation class? So you need to find out it. In the implementation class you will get everything. So let's say this array list here. So if you open the array list related constructors and methods, everything you can see. You can check all the collection related methods as well as the list related methods. Each and every method is available under this particular collection. So mainly what we need to understand is, so which class is the implementation class. So this is very important. The implementation class basically it does not contain any name like public class or something like this. So whenever the class which look like this, like public abstract class, so this particular class basically it is not yet implemented all the methods. Okay, so here we cannot get all the information, like 100% the methods are not yet implemented, but all the methods are implemented under this particular class called array list. So this is the way you need to understand which is the implementation class. So this is the array list is the implementation class for list interface, because list internally it is extending from the collection. Okay, so this is what we need to understand. So this is the way we can understand it. So same way we'll discuss here base tree. Base tree basically it is an interface. It is an interface. So if you want to know the this iterator related information, split iterator, yield parallel, everything. So where we can check it? So whenever it is implemented from this particular interface. If you know the implementation class, so that we can understand it, which type of the class is implemented, iterator and the split iterator, so parallel, yield parallel, so whatever the method we are having. Okay, so first we need to understand the interface and we need to understand the method so that we can understand it. So what exactly the stream it is going to provide and what are the methods we are having to work with this particular streams here, because this is a predefined interface. So this particular interface we did not define. Okay, so this you can see here. So from the 1.8 we are getting this particular base stream class interface. Okay, now we understand it. So this is the base interface for all the stream operations. We can do the sequential operation as well as parallel operations. So using this particular sequence. And what we understand is, here the base stream basically it is a generic concept. Here what we are doing is, here we are providing the T and S, and internally if you observe, it is extending from this particular base stream. Internally it is extending from this particular base. So what is the base stream here? So this is the sequence. Okay, so now whenever we are trying to provide this particular S, it should be extended from this particular base stream. It should be extended from the base stream. So this is very important. Whenever we are trying to work with the collection framework, so we need to understand the generic concept. The generic concept we already discussed in the previous matches here. Just go through all the generic classes, what are the examples we discussed. Now you will understand regarding this particular base stream and the particular piece called generic type. Okay, so now we understand it. Now here what we are doing is, so these are the abstract methods. These are the abstract methods. So what exactly the abstract methods are containing? Now you can see this is a sequential method and it is trying to return as a generic type ES. So same way parallel we are having, and it is trying to return the S, and unordered method we are having. So on close and close methods. So these are all the abstract methods we are having under this particular interface called base stream. So what exactly it will do? So let's say the close method. Now what is saying here? Close this particular stream. If we want to close after performing all the operation, so we can close. Okay, so we can close by calling the method called close here. And what about this particular unordered method? What is saying basically here? Here, so it is trying to provide the important call. So returns a equivalent stream that is unordered. Okay, so the name of the method itself is trying to providing the important information call. We are not going to get in the order. So the random value it is going to pick up and it will try to return it. So that is, so we can understand the unordered return. Okay, and the above method, parallel. So parallel, what exactly it will do? It is trying to return the parallel stream based on the invocation, based on the particular stream on top of the which stream we are going to be called. Parallel means, so it is going to be executed at a time with the multiple threads. Okay, so sequencer basically it will try to work with one by one. Okay, let's say here I am having collection. So this is a collection of objects we are having. These are the collection of objects I am having. Now whenever I am working with the sequencer, what exactly it will do? It will try to work with the one by one. Like first it will execute, second it will execute, like it, third, fourth, like it will execute it. So whenever I am trying to execute the parallel, now basically parallel it will work with the multiple threads. So at a time, these are the tasks are going to be completed automatically. Okay, so it is not going to be dependent on the other threads. Each thread it is going to be executed, so their own part. But whenever we are trying to work with the sequences, one by one we take. So one thread is completed, second one will completed, third one. So this is, we can call it as a sequencer. Okay, so we'll see what exactly the parallel and sequencer will do. And here, so what is the Boolean parameter we are having here? Here you can see, so E is parallel. So simply it will return whatever the stream we are working is, whether it is a parallel stream or it is a normal stream. So it will try to return the Boolean. If it is the parallel stream, we will get the true, otherwise we will get the false. So we discussed the split iterator. So it is a 1.8 split iterator. What exactly it will do? It will do the important call. It will try to work with so iteration object, but here we can work with the lambda related operations so using this particular switch iterator. So we already discussed it, but again we'll go for the one more example on the stream basis example. So we already know iterator. Okay, now so the parallel basically we can see here, so returns the equivalent stream the parallel. So what is saying basically the stream, it will work with multiple threads. So only the main differences we are having sequential parallel. Parallel it will try to work with the multiple threads so that the performance we may get a little bit faster compared to the sequential. So we'll see so what exactly the sequence and parallel will do with the time frame. Okay, so basically when we are trying to work with the multiple threading, we can go for the parallel. So whenever you are not working with the multiple threads, so one thread we are going to be working at a time, then we can go for the sequence. This is only the main difference we are having, parallel and the sequence. Okay, now another important section basically the base stream, it is divided the several type of stream interfaces. This is the base stream. Now another important thing basically here you can see remove this particular base here. Now you can work with the stream. Now if you observe carefully, so this is the one more interface called stream, and here we are having this particular generic type here, and internally it is extending the filter. Okay, so what you are understanding now, so base stream is the super interface, and the super interface now it is extending from this particular stream. Now it is extending the particular stream. Okay, now here what we can identify here we are going to have multiple methods. So if you remember here, whatever the operation we are doing, let's go. So stream we are calling filter method, map method, and sum method. Okay, now here, so those information we can get. Now you can see filter, but if you observe carefully, we are passing the predicate. So what is the predicate? Predicate is one of the functional interface. Now you can see this is one of the functional interface, and here we are having a test method. The test method is expecting the one parameter. The parameter type is a generic type. Okay, and what we are doing, so this is the abstract method which is going to be used, and second one is default method. So this is the default method. So these are the default methods we are having, and this is a static method. Okay, default method and static method. But only one abstract method we are going to have whenever we are trying to work with the functional interface. Okay, so now what we are doing, so it will try to return the boolean. So based on the condition, whatever the condition we are going to provide, if the condition will return true, it will try to do the filter. Okay, so whatever the condition we are going to provide here, based on the respective condition, it will do the filtering the current collection function. So we'll see what exactly the filter will do. Now if you see here, what we are doing here, so here we are doing the based on the color. Okay, what we are doing is, so based on the color. So w dot get color, if it is equals to red, so those records only we are fetching. Okay, those records only we are fetching under this particular filter. So it's simple. If you want to do the filter based on the color, account, salary, name, whatever we are going to have, so that is we can do based on this particular filter. And filter internally, it's trying to take the parameter of this particular predicate. Predicate is one of the functional interface, and it is having the one abstract method called test. So the test state is trying to return the boolean based on the respective condition is true. Okay, so this is what we need to understand here. So this is the filter method we understand it. So simply just we are trying to filter it based on the some criteria, or we can call it as a some category. Okay, map. So what exactly the map will do now? So map is also one stream method. So what exactly it will do? It will try to see, if you remember the functional interface, how it is going to be used at runtime, the method it is going to be used, because it is an interface. It is an interface. So if you know the basic example of this particular lambda, here also we use it. Now if you see here, this is the my function. We are doing the int function, and here we are trying to use the type of array and values. So where we implemented here, So here if you see, here we are calling the my operation and we are passing the my function. Now using this particular my function, what we are doing is we are calling the function dot function C. So the function C, this one. So this is the function C method we are calling. But here if you see carefully, we did not implement the method, but directly we are calling this method. So where this method is implemented, wherever we are passing this. So now this particular piece of code, now it is going to be provided under this particular method called function. So this method. Okay. So we'll see what exactly the filter method and the map method will use here, because so you did not understand the lambda. So we already discussed these many examples in the lambda. So just review the lambda related, you can easily understand. So otherwise, once you familiar this particular method, we'll discuss the one example with each method, how exactly it is going to be implemented. Okay. So come back to here, the Steam API. Now we are trying to discuss the map. Map basically what exactly it is. So if you see, this is a predicate is a one functional interface and the function. Okay. Function is also one more functional interface. So what is the method we are having? Apply. Okay. If you observe carefully, this method is trying to return the return type. This particular apply method, it will try to return the object. But whereas the predicate, if you see, it is not returning any object. It will try to return the Boolean value. So just we will get only true or false. But whereas the function will get the object as a return. Now, so what you understand? So basically, we can understand when we are trying to work with the map here, the object it is going to be changed. So one object into another object. If you want to do the conversion, or if you want to convert the object, so then we can call this particular map. Okay. Now if you see here, we are calling the map to int we are calling. Okay. So this is also similar method. Okay. Map and map to into, map to land, map to double. So these are the similar methods. What we are doing basically, so W is an object. Okay. So this W is a widget object. So now you see, so we are having, okay, so basically what we are having, it is a widget is a, let's say we are having special object better, or we can call it as, in place of this particular widget, if you remember, person we are having, or we can call it as a person list. Okay, person list. Now what I am doing here, so based on the person list contains collection of objects. Now what I am doing here, I am calling the stream here. So this is the stream method. It will do the interface for stream type. Now after that, what I am doing here, I am calling the map here. Now here, so map is expecting the function. Map is expecting the function as a parameter. Now in place of providing the function, now what I am doing here I am trying to work with the lambda. Okay, here I am trying to work with the lambda. So the lambda internally it will work with the function interface. Lambda internally work with the function interface. Now if it is working with the functional interface, now what is the function apply method? What is expecting? Type is expecting. Okay, type is expecting, and it is a one parameter. Now here what I am doing is, so I am trying to providing only one parameter. For the one parameter, no need to provide the brackets. Okay. Now here what I am doing is p dot name of column. P dot name. Now what you understand is, so p is a person. From this particular person list, I am trying to pick one by one person object I am picking. From the one person, I am calling the p dot name. So p dot name, it is a string type. Name is a string type. Okay, name is a string type. But person is the object. What we are doing here? From this particular person, we are converting into the string type. But here, what are the objects we are going to be doing? Only name of the person. Only name of the person. We are not loading the entire object. From the person. Okay, from this particular person object, just I am trying to load only names here. Now finally, what you will understand. So here I am having 10 records. 10 person list I am having. Okay, whenever I am having 10 person list, so each person list we are going to be loaded based on this thing, and will print the only name of the person. Only name of the person. The 10% we are going to be print only that contain name. But person object can contain ID, name, something like email, and so something like we discussed the department. But here, instead of loading this entire person object, what we are doing here, we are loading only the names. Only names. This particular box will print only names. But whenever I'm trying to print this particular person list, it prints like this. ID, name, email, department. Okay. From the person, if we want to load the specific object information, then we can use the map. Then we can use this particular map. Okay. From this particular person object, and we convert it into the string because of the name we provide the data type as a string. Okay. So this is the main important. The map basically it will call the apply method and it will try to return the one object. So that is called string we are going to get. So this is the one more method. So just observe this. We can have each and every method with an example. How exactly these exams are like these methods are going to be implemented. Now you can see map to int. So what we are doing basically here, whenever we are trying to work with this particular map to int, we'll get the integer related. We'll get the integer related value. So same way long related. But here what we are doing is toInt function. So toInt function is also one more functional interface and it is having apply as an int and we are passing the type parameter and we'll get the integer. So same way we'll get the long also. Too long. So this is the long one. Okay. Now same way double get. Okay. Flat map. So what exactly the flat map will do now? What exactly the flat map will do? So if you observe, map and flat map will do the same. But only the difference is, so internally if you see function, here we are passing the function and we are having a question mark. So we should work with only the X type, the generic type T, and internally, so the second parameter. The second parameter, what we are doing, so it should extend from this particular R. It should extend from this particular R. Here, what we are doing here, so you can see the flat map, what we are doing here. Again, I'm passing the stream of. Okay, stream of means again we are passing the collection of records. So we'll see the differences between the map and the flat map, so that we will understand what exactly these two methods are implemented. And you can see so similar method: flat map to integer, flat map to long, and flat map to double, and this. So what you are understand this method? So the name of the method itself, it is giving the information. So unique values. Okay. So unique values will get it. So, and you can see the one more method sorted. We'll get it the natural sorting order. Natural sorting order. So instead of working with the tree map or tree set, whatever we implemented in the initial days, but directly what we can do, so using the stream API, you can call the method called sorted. It will do the natural sorting order. Okay, here you can see it will try to provide the sorted according to the natural order. So now you can see sorted. But if you are not interested in the natural sorting order, what is suggested? Provide the comparison. Okay, so we already know. So when we are providing the comparison, we can work with a different sorting behavior. So that we can provide the sorted. So sorted without taking the parameter, the same sorted method which is taking the with the comparator as a parameter. So this is we can understand. So this take method. Now if you see consumer, what exactly the consumer is doing here? What exactly it is doing? It is not doing anything. The accept method, it is not doing anything. Now what you can understand? If it is not returning anything, then we can work with this particular interface called consumer. Okay. So finally, what you understand here, this particular print method, simply what we are doing here, we are trying to print the value. Here we are trying to print the value because the consumer, it is not going to do anything. So simply it will return the void. So instead of returning the void, what we can do? Print the respective data. So this is, and here we can provide the limit. Limit basically how many objects we want to get, so we can provide the limit. Okay. So same with skip method. So skip, like the second iteration I want to remove, like I want to skip here, third iteration I want to skip, then we can provide the skip and how many iteration we want to skip here. Okay, so this is the skip method. Now another important, these are the default methods. These are the default methods. So now first we'll focus on the abstract method, because these are the methods does not contain the body. So we can call it as a abstract method. These are the abstract methods, whatever we discussed. But default method, you can see it is opening bracket and closing the bracket, and internally we are doing this. But here internally again we are calling the stream support.stream, and we are doing the different type of operation. So we'll see the default method how it is going to be worked. You can see the default method how it is going to be worked. So finally, what do we understand here? Here we understand the stream example. The main interface is base stream. The base stream is having some of the abstract methods, and the stream interface is having so few more abstract methods. And all these abstract methods are implemented by which class? Okay, which classes this particular methods are implemented. So we are having lot of abstract methods we are having. So we'll see one by one of what exactly this particular methods are implemented. And another important section basically, so how we can use this particular stream. So if I want to use the stream basically, so what we will do, we'll call the one stream method. So let's say I'll copy the array list section. So where we are having array list and list. So this is we already discussed here. So the same example I'm trying to use here. Okay. Now this is a array list here. So anything we are having, right? Now what we are doing is, now here based on array list dot, what is the method I'm calling it? Stream. But if you see here, the stream is expecting the generic type. The stream is expecting the generic type called T. Okay. And what is the type? Automatically it will convert, because here if you observe carefully, array list internally it is also expecting the generic type. The same generic type now it is passed to this particular stream. Okay. But this stream method is implemented where? This stream method is implemented under the array list. So if you see here, now I am under the collection, and it is a default method. So what is returning? So it's trying to return the stream. So stream basically it is an interface. So whatever we discussed just now, the same interface. Okay. Now we understand this particular stream here. Now what we are doing here, we are calling the stream support. So what is the stream support basically? It is one of the final class. And so using this particular final class, now what final class means, this class it is not going to be extended to any other classes. Okay. So now what we are doing, after this what I am doing, I am calling the stream method. But here if you see, without creating object of this particular stream support, we are calling the stream method. So what we can understand this particular stream method, the type of this, it is a static here. Now you can see public static. So this is trying to return the stream. Okay. Now you can see what we are having. This is the stream method, and it is expecting the split iterator, and we are trying to work with the Boolean parameter. This parameter. Okay. So now what we are doing finally, here we are trying to create object of this particular new reference pipeline.head, and by providing this particular all the required information. So what we are understanding is, if I want to get the stream object, so split iterator we already discussed, it will do the same behavior like the iterator, but only the main advantage will get here. So if you want to work with the 1.8 related operations, like if you want to work with the method reference or lambda related information, so those functionality we cannot work with the iterator and distributor, that we can work with this particular split iterator, because here we are passing the consumer is one of the functional interface. and here also we are passing the same consumer. Okay, so here we can do the two methods. We can call the try adverse, or we can go for the default method called for each remaining. But here we can pass the method reference and the lambda expression. So same way here also we can pass. But when we're trying to work with the iterator, we cannot pass the lambda related operation. We cannot pass because this interface is implemented from the 1.8. Whenever it is implemented, it will support the lambda related operation. Okay, so this is only the main difference here. So same we will have here also, like whatever the next value, previous value, whatever we observe in the iterator, so same way we can work with this here also. But only the main difference is we cannot work with the lambda related operations with help of the iterator. So those we can work with the script iterator. Okay, so because of that, here we are providing the script iterator. Now here, whenever we are calling this, now what we are doing, we are calling this particular script iterator, we are making the parallel as a false. Okay, by default, so it is not going to be called this particular factor. Now we understand this. But how we are getting the same object? By calling this particular stream support.c. Okay, so now we got the same object. Now we got the same object. Now whatever we discussed, so far we discussed the filter. I am calling the filter method. So now what exactly the filter will do now? What exactly the filter will do now? So here, now what I am doing is, I am trying to providing the list here, and here, and here. So if this particular condition is, so these are basically, okay, now if you see here, what we can understand here, these are the methods, basically it will try to return the boolean. These are the methods, or it is going to be return the boolean. Okay, so now here, list.add you can do here, so contains, remove, anything you can check. Anything you can check. So now, what I am trying to check here, contains. Now here, what I am doing is, so something like this is the value I am trying to print. Okay. After this, what is the object we are getting is stream value, because the filter method, if you go to this particular stream, it is returning the stream type. Okay. This is the method we are using filter, but this time to return the stream. So same way we got this. Same way we got this particular stream object. But now, if you are not interested to do this particular stream object, what you can do? So we can do the, okay, so collect, and we are passing this particular collect to collector.tool. So now we can convert into the array list. So that is we can discuss later, but as of now, observe carefully collector method. Now after that, I am trying to print the collect. After that, I am trying to print the collect. So carefully observe what is the result we are going to get now. So nothing yet. Now here I am going to print the same result before doing this particular filter operation, and after doing the filter operation, now I am trying to print the result here. Now you can see, so before doing the filter operation we are having these objects, but after filter we are not getting anything. So why we are not getting anything? Can you guess it? Okay, so we need to understand this particular. So whenever we are trying to work with this particular elements here, the contains method basically what exactly it will do now? The particular contains method, whatever the value we provided, if this particular value is available, it will try to return as a true. Otherwise, it will return as a false. But in our case, what happened here? We'll get the false here. Whenever we are getting the false here, what happened basically? It is not going to add the particular records into this particular color. Okay, it is not going to be add the particular record. So the filter, now what you understand here, if you want to do any condition, if the condition is returned true, then only the record it is going to be added. So let's say I want to provide the 456 here. Just I want to check the content with the 456. Now if you see here, whenever I'm trying to work with this particular 456, the 456 is available, and again we are trying to get the stream records. Because the stream and we are doing the filter. Filter one by one it will check the records. One by one it will check the records. So each record, what we are doing is, here we are trying to check this particular content here. Based on the content, now we are going to do this operation. So this is the one way. And another way, what you can do, you can check the so list here we are having. Now what we can do is, here we can check the equals method. Okay, list dot. Now I want to equal only this particular 456. Now what happens? Now you can see only one record, because we are comparing the particular 456, only one record will match the particular record here. But finally, what we are doing, this is the lambda. Okay, this is the lambda we are doing. But here, what is expecting the particular filter? It is expecting the predicate. But in place of providing the predicate object, now what we are providing? Lambda. Why we are providing lambda? Because this particular operation, this particular logic, it is going to implement it under the predicate method called text. Okay, but this implementation, it is going to take care of the runtime. So this is what we need to understand. Because of that, here the iterate also it is using the Java related features. Okay, so now ignore this particular correct method, what exactly it will do. But as of now, we are discussing the filter. So any questions on this? Any questions regarding this particular filter? Okay. So now what do we need to understand basically? What we can understand basically here. So to work with a map here, now we need to have a person related example. So where we use this particular person related example. Maybe collection 2, I think we used here. Yeah, here we are using the number. So this is the okay. So we can work with this particular person related here only. Now what I'm doing is I'm trying to create a same object here. Here now I'm trying to create a same object here. In place of the string, now I'm trying to provide in the person. So collection framework person I want to use here. ArrayList.add. Now so ID, name and email. ID I'm giving, name something like theme I'm going to give, and email email.com. Okay, so this is the one record. Okay, so we can work with the 4 records here. So let's change the 456 here, and the 789, 74, and so one is the theme, second one is the array list, and another one is the list, and the last one is okay, so base. So we can keep this particular email related as it is. But now what I am doing here, array list dot, so same method we can call C to get the C object here. Now after that I am trying to call the map. Now understand what is expecting function. Okay, and if you see the function, generic types are important. Function generic types are important. Sorry. Go to the map here. Now here, try this map here so that we'll understand. Now here you can see this is a map and here we are calling the same. So function. Okay. So question mark super T. What is the T here now? What is the T? The T we are having currently person. Okay. The T we are having currently person. Now, whatever the question mark here we are going to pass it. So it should be the super to this particular T. It should be the super to this particular T. And the second one is, and the question mark, and internally it should extend from this particular R. It should extend from this particular R. Now here what you are understanding, if you observe carefully, now here you can understand question mark we are keeping as it is, but super it is in place of T, it is replacing with the person. Okay, so question mark extending R. R we did not provide it as of now because that is a written type. But how we are going to work here? Now if you observe, okay, here I am passing the person dot what we are doing here, name. Now you can see here. So question mark super person and question mark extend string. Extend string we got it. Earlier we did not get anything. The still it is a R. But currently you can see here. So in the small letters we are able to see string. Why we are getting the string? Because here we are calling the name. The name type, what is the type we are having here? The type we are having as a string. So if you go to the collection, so name we are having a database called string. Okay, so now we are calling the name. So after that, so same we can do. No need to do the filter. We can go for the connect here, and this object we can print now. This object we can print. Okay, so now if I am trying to print this particular object here, now we'll see. So stream, array list and base. So these are the names we provided. These are the 4 names we provided. And another one, before doing this particular stream operation, now I want to print the array list. Now we'll understand the 2 examples. Now if you see the first example, like before doing the map operation, what we are printing? Person ID, name, email. Okay, this is the first number. So person ID, name, email. So same way person ID. But whenever we are doing the map, we are getting only names. Now what you understand is the map basically it is converting one object into the other. So what is the object we are using basically? Here we are providing the person object. But from the person object, now we are loading only names. So this is list of string we got. But what we are working? List of person. So array list person also same and list of person also same. So if I am going to change here, so what is saying basically, this is the 2 list basically, it is trying to return the list type. Because of that we are getting the list, but its array list is one of the implementation. It will work. Okay, what is saying? Do the conversion. Okay, so do the conversion. Now finally observe here, array list string, but original object is array list person. With the original object array list person, whenever I am using the map here, now we got the different data type result. So that is called stringing. So this is the way the map it is going to be work. So whenever we want to load the specific data, then we can go for the mapping. Okay, so is it understand? Any questions regarding this particular map? Okay, now what is another method we are having? See, super basically, whenever we want to call the super related behavior, we are going to use this particular super key. So extend again it is a inheritance. inheritance. Like this is a super class. Now whatever we are providing, the class it should be extend from this particular R, or else the class it is a R. Super behavior means basically here we are having. Let's say, okay, in place of T, so what we provided as a person we provided. Okay, person we provided. And here, now what I'm doing is, let's say I'm going to provide as a member. Okay, and there is no relation with these two classes. There is no relation with these two classes as of now. But whenever I'm making extension, the member will work as a subclass and the person will work as a superclass. The person will work as a superclass. So here, what is saying here? So in place of question mark, if I'm going to provide as a member, now member internally it is extending this particular super, so it is having the super behavior of this particular person, and the size we also provide the same person, so it will match. Okay, whenever we are not doing this particular action here, so this particular class does not know the information about this particular person, then there is no behavior of this particular super. Behavior means it is not going to be extended this particular person class, and the person, like the member, does not have information anything regarding this particular person. So observe carefully. I will show you the example. You will understand it. So now math we provided the person. So in place of this particular person, what I will do? Member will get the person. And what we can do now? Let me work with the member on this. These are expect name, email, department. So name, ID given, name, something like member, email. Okay, something like department. So we created the member. Now here, member dot get name. So now understand here what is saying this. Member 1. So this is the, but here member 1, member dot get name. Okay, now what is saying basically here? So here, if you observe carefully, super com.core Java collection framework person. Okay, and what we are passing now? What we are passing basically here, the question mark we are passing as a number. The question mark now we are passing as a number. So there is no relation between these two now. Okay, here you can see what is saying. There is a no instance of type variable s exists, so that the person conflicts to the number. Person conflicts to this particular number, because this stream we are passed the person, but whenever we are working with the map, what we are doing is we are working with the map. But here the map and person does not contain any references. Like there is no relation as of now. But how we are going to get the relation? So now this is a person is coming from the where? I score. We are also working with the same numbers or any other number we are having. And here if I am trying to work with a let me provide the method for it. From the person we cannot get the number. Okay. So how we can, so these are the person related information only we can get. So question mark super T. Let's get super extended. Okay, so I need to find out one example on this particular super, but currently, so whatever we are doing this is also one important example regarding the super keyword. But with the method references we are able to achieve, but I am trying to work with lambda here. So I need to provide the simple example on the number and the person. So as of now we don't have a relation here, because of that we are not able to figure it out here. So I will show you the one example regarding this particular this part. Okay, so whatever I'm highlighting, so I can show you in the tomorrow session. But as of now, you can see, so what I'm trying to explain here. So basically, we can easily understand this is basically, it is a condition. This is basically, it is a condition basically. So here one condition and this is the second condition. Whenever we are trying to work with the generics here, so instead of giving all the objects to work with this particular function, what we are doing is only the special type. The special type how we are getting based on this particular T. Okay, so it should be the super to this particular T or it should be external to this particular R. So I will show you the two examples, one this particular part and second one. I need to create one example to provide the super related example. Okay, so we see that example, but another important section what I'm trying to explain, we need to work with the map to int. Map to int here. So if I want to work with this particular map to int, what we can do now? So to work with this map to int here, what we can do now? Again, we can call this rlist dot stream dot map to int. Okay, map to int here. So the map to int basically what is suggesting is the object now we are converting into the integer. How we are going to convert here? So simple here. Person get ID. Okay, it is a long. So in case of this particular int, we can go for the long. We can go for the long. And here what I'm doing is map to long I'm getting. Now this particular long we are going to get. So let me print this. Because the person dot get ID, whatever the ID we are having, the data type is given as a long. Okay, so now you can so what is the object we are getting here? A reference pipeline. It is an object we are trying to see. But here, any value we are getting here? Any value we are getting? Here you can see these are the methods. But these methods are coming from the way So some method and map to int, max method, min method. Again, from where we are able to see here? So we are getting from the same scene. same object. Now here you can see if I am going to work with the collector, what we can provide here, collectors dot to list. So what is happening basically, the list what we are providing here you can see, so these many conditions we are having. So A, T, these are the generic type conditions we are having, so it is not matching. It is not matching. Okay, so what we can do now, here instead of loading this particular ID, because here if you go to the theme, map to long we are getting the long, map to int we are getting the int. Okay, so these are the again stream objects. Now if you go to the int stream, internally directly it is extending from this particular base. Directly it is extending from this particular base. So I will get the filter method, map object, map to long, map to double, and again these are the different type of methods we are having under the int stream. So when we are trying to work with this particular operation, up to this particular operation. Now, what you understand here, so we'll get the int stream. From the int stream, these are the methods now we are getting. These are the methods we are getting here. Okay, so what we can do, we can call the to array, it will try to convert into the long array. The same long array we can print here. Or else, what we can do, we can go for this particular for each here. Now we can print it one by one here. How I am trying to print it, system dot println, system dot out dot println. Now you can see again I am trying to print it all the IDs. So now you can see 1 2 3 4 5 6 7 8 9 7 4 1. Where we provided, these are the objects. These are the IDs we loaded. So now you can see only the IDs we loaded. How we loaded? So using the method called map to long. So same way it will work, map to double, map to int. But here the person object we created as a ID as a long title. Okay, so these are the similar methods are going to be work. But again, if you observe, each method internally it is having the one more string. Internally it is having one more string object. So how we discuss the particular int string. So same way we are going to have multiple strings, long string, double string, and any other strings. So platinum again we are getting the int string. Okay, so similar methods only. So same method we can identify in all the int stream, long stream and double stream. So like filter method, map to object, map to. So these are the similar methods we are going to have here. So let's say here after this particular map, now if I want to go, so filter method and long predicate. But here you can see, here we are providing the same filter int predicate, because this is the int string. Now if you work with the long string, the predicate is different, int predicate. But if you can see, the int predicate internally it is doing the same. So this is the name of the interface we created as int predicate, but the same boolean test and the same default method, same whatever we observe the predicate, same copy and paste it here, but only the naming convention int predicate is provided. Okay, and it is not a generic. So same way we are going to have int predicate, long predicate, double predicate. So here you can see double predicate. So this is a double predicate. So same way long predicate. Okay, so these are the different type of interfaces, like functional interfaces added in the 1.8. So once you are familiar with this particular thing, you can easily understand what are the different type of things we are having. Okay, so we'll continue tomorrow. Like mainly we need to discuss the map and map into maplan, and these are the methods we completed. We'll discuss about the flat map, and after that, so we'll try to discuss about these are the different methods. So mainly the illegal state exception, basically whenever we are trying to change the state of an object. Okay, so when you are trying to execute something in the middle of loop, if you are trying to add or if you are trying to delete, the state of an object it is going to be changed here. So at the time of this, so you will get an exception. No, now if you want to see this, so this is a illegal state here. So you can see here signals that method has been invoked an illegal or inoperative time, inappropriate time basically. So it's simply saying whenever you are trying to work with the state of an object, you are modifying anything, so we'll get to this type of exception. So in other words, the Java environment or Java application, it is not in the appropriate state. Getting the point. So it's a simple understand basically. Whenever we are trying to executing the one object here with one environment here, if you are trying to change something, if you are trying to change the object here, so then this type of exception we are going to be fixing. So to fix this, basically we need to check what type of object we are trying to modify it. So based on that only we can fix this particular exception. So we need to understand the where exactly you got the exception, in the which scenario you got an exception. So what is the case to resolve the particular exception? Then only we can identify. Okay. So it is a simple. Now we are under the illegal state exception class. So just click this icon. In the IntelliJ, you will see this particular icon. You can click on this particular icon. You will go to the where this particular file is available. So now we are under the illegal state exception. So this is having under the JDK 11 version and under the LAN package, under the java.lang package. Now we are having this is the particular class where I coded illegal state exception. Yeah. So this is the way you can check any class. So if you want to check the person class, and if you click on this particular circle, now we'll go to the person. Same way click on the string. Now under the string, again click on this particular circle. Now we'll come under the string. Okay. So any questions? So we'll continue tomorrow. So we'll try to continue the continuation of this particular string API methods.